Hey, what up folks, this is GK. So in this video, I'm going to discuss about the application deployment strategies. This is a very important concept to understand not only for the DevOps or the system administrators, but also for a solutions architect. You have to understand different deployment strategy patterns and how you can apply for your company based on your company needs and business requirements. So I'm going to talk about the different deployment patterns, and I'm going to give you the key benefits and as well as some of the considerations that you should make when choosing the deployment strategy. And most importantly, you would know that if you're working in a company, which strategy works for you based on the application needs. Do watch till the end because you should not miss the different strategies, the different patterns. And also, this is a key concept that's often been asked in DevOps or architect interviews. Suppose you want to upgrade an application which is running in production, right? And you want to deploy that application and you want to make sure that the application is running with less downtime, or there are a lot of other factors that play in when deploying your application. These are some of the considerations that are commonly applied when deploying an application in the production. The first consideration is application downtime. It all depends on, again, the business requirement, because business drives whether you can have a downtime for your application or you can live with the downtime. So that's number one consideration for a lot of companies. And second one is how you're going to resolve the incidents with minimal impact on the users. So for example, if you are doing a production deployment and if there is an incident that happened during the deployment, so how you're going to mitigate that without impacting your end customers. Address failed deployments in a reliable way. So this is a quite common scenario for if you're working in a company. You often see that the deployments fail in production. So what are your rollback strategies to roll back to the previous version, or how you're going to overcome that in an effective way so that it's not going to impact your end users? And minimize people and process errors. And this is the most common thing that occurs in the enterprise companies, because when you have people and process related issues, it's complex, and it becomes even more complex with more teams and different hierarchical organizational structures. So how you're going to minimize that, and how you're going to achieve a predictable, repeatable deployments. So if you have a deployment CI/CD pipeline that you set up for the production, how you're going to achieve the same repeatable process for every deployment that you're going to deploy for application. So that's important. So these are the considerations that you would keep in mind whenever you're deploying an application into production. With that, I'm going to go over the deployment patterns. So these are the deployment patterns, and as always, the timestamps are in the description. You can skip to a specific pattern and learn about that directly if you are aware of any other pattern. But I strongly recommend, if you are new to this concept, go over each pattern, because these patterns can be applied to any cloud service provider, whether it is AWS, GCP, or Azure. And fundamentally, this would decide how you want to deploy your application in production with choosing one of these patterns. So now first, we want to discuss about the recreate pattern. Like I've said before, the main criteria of choosing a pattern is not just the pattern is going to be effective for your company, but it's more how your business drives the requirement. For instance, so we cannot say like one specific pattern is good. Like we cannot say blue green is good, or we cannot say canary is good. It depends on business requirement and the criticality of the application that would drive the pattern. So keep that in mind always. Whenever you go for interview, if somebody would say, is canary deployment better, or is a blue green, if blue green deployment is better, if they ask you this question, first gather the requirements of understanding what is the criticality of the application, what are the business requirements of the application, and how many users, etc. So once you have enough information, then you would decide which deployment pattern matches that application, suits that application. With that, we're going to discuss the basic first pattern, which is recreate deployment pattern. So this is a very simple pattern. Basically, you have your current version 1 application running. Keep in mind that your application might be running in a auto scaling group or managed instance group, or even a non auto scalable instances, meaning you can have EC2s or you can have Kubernetes here, whatever you want to have here you can have, but you have a set of users that are actually using version 1 of your application. So now in this deployment model, what you would do is you would try to update all the instances with a newer version, with version 2, and then you would start back the traffic on the newer versions. So this is a very simplistic approach. And here, obviously, if you look at the key benefits, it's very simple and it avoids any backward compatibility challenges. We're going to discuss about the backward compatibility challenges, but at a very high level, which means that you are going to give your customers either version 0 or version 1. You're not going to mix and match version 0 and version 1 or have parallel environments serving two versions. So that's the backward compatibility issues that we would see in the next deployment models, but we're going to avoid that here completely because we are just going to deploy one version. These are the key benefits, and the considerations here are: can your company live with a downtime? Because as we were discussing in this diagram, we would deploy the version 2 completely, and when we are deploying version 2, we have to stop the instances and deploy the version 2. So there is a downtime, a specific downtime that's going to be there, like maybe it's 1 hour or whatever the time the deployment is going to take. So the downtime is there, and your application's SLA would define the downtime. So if you are new to the concept of SLA, please go back to my SRE video. You would understand the different terms like SLA, SLO, and all those key terminologies. And I'm going to have the link in the top right now. So the main consideration again here is it doesn't apply for a mission critical application where your customers are using your application 24/7. This is suitable more for an application where you can have a downtime specifically when deploying. So this is a very simple pattern. Now the next pattern that we're going to discuss is the rolling update deployment pattern. So here what happens is you have the initial state. So you have users and load balancer, and load balancers have bunch of EC2 instances or GC instances or containers or whatever. And if the current set of instances are serving version 1, so in the rolling update, what you would do is, so you would pick one instance out of this, you would apply the version 2 to that, and then you would do basically rolling. So you pick second instance again, and you would apply the newer version to that, and then you pick the third one and you apply newer version to that. So that's why it is called as a rolling update process. And now you might have this question like, if there is a traffic already that's been served on version 1, if you're trying to remove one instance, what would be the impact of the load? That's a very valid question. So in that case, you would either increase the number of instances during that point of time whenever you're doing rolling update, and then you would choose the window size and pick the number of instances that you want to slowly update. So that's a strategy behind this rolling update. It depends on the load, and generally people do it during the non-peak hours whenever there is less load. So talking about the key benefits here, we're not going to have any downtime because we are doing it based on the window size. You incrementally update the deployment targets, and if it can be 1 by 1 or 2 by 2. You direct traffic to the updated deployments only after the new version of the application is ready to accept the traffic. So there is no downtime at all here. And the other key benefit is reduced deployment risk. When you roll out and update incrementally, any instability in the newer version affects only portion of the users. If you go back and see here, after we put 2 instances to the version 2, if there are any issues, it's going to affect a group of users which are targeting the version 2, which has the newer functionality of your application. So the users who are currently using version 1, they won't be impacted. So there is only a subset of users who are impacted whenever this deployment happens. So now let's look at the considerations, and these things you have to keep in mind whenever you want to choose this deployment model. And it's a slower rollback, obviously, because if there is a issue that happened in one of the instance, the rollback is going to take a lot of time, as you have to do a rolling rollback update back again to the version 1. It's not easy to roll back, and it's going to take time. And the other issue is the backward compatibility, because the new code and old code, as you can see here, the new code and the old code are existing side by side. So let's say that a user 1 is currently accessing version 1 and user 2 is going to access version 2. So if you release a functionality that has issues with your backend code or database, or it's behaving a little bit differently, you have to make sure that your application is backward compatible to both version 1 and version 2. And often what happens here is, like, when the users are trying to refresh their browser, or they refresh their browser, or they have killed the session, or they logged out of the session, whenever they log in back, there could be some sort of cache data that is still on the browser, and if that user is now directed to a version 2, he should not, or she should not, have the compatibility issues with version 1 and version 2. And the other factor is sticky session. So sticky session is nothing but if a user is talking to an instance through a load balancer, for duration of that session, the user will keep talking to that instance. So that's called sticky session, and we want to keep user to that instance alone. So that's the whole reason behind the sticky session. So in this strategy, it's important that we have to maintain the sticky session through a load balancer, so that supports the sticky session, and also the connection draining, which is supported through a load balancer. And it's also better to have session sharing through a data store, through like Redis or some other caching mechanism. It's better to share the session between two different versions, so that the sessions can be completely decoupled from the underlying resources. So that's about the rolling update. Now we're going to talk about a very famous blue-green deployment model, and a lot of companies follow this deployment pattern, and this is the most important deployment pattern that's commonly asked in the interviews. This and the Canary, which we're going to discuss next, are the super important deployment patterns. So the blue-green, also previously called as the red-black deployment. So what we do here is, basically you have two sets of deployments. So currently the users are talking to a blue set of instances, meaning that you maintain two different infrastructures for your application. The current set of users, or the live traffic, is currently being served to the blue. And then now let's say you want to install a new version, v1 or v2. So you would create first a completely different application, and set up auto scaling or all those things, and install the application v2. And then if you want to deploy, if you want to test anything, you would test it here. You would do all the testing here with your sample data, with your automated tools. And once you feel that you are confident, what you would do is you route the traffic to the green, and again you would use the strategies of connection draining and stuff here, so that the existing users who are connected to the blue, they would still be connected unless they disconnect at some point. And then the load balancer send the same user again when he or she logs in back to the green. So after some time, after you feel that everything is fine in green, there are no issues, things are looking good, no major issues from the end user's perspective, you can either decommission blue, or you can still use that for your next version, like v3 or v4 in future. You can use this blue to stage your code, then deploy your code, and follow the same strategy again. So this is the blue-green deployment strategy. So the key benefits of this are no downtime. As you can see, there is no downtime here, and instant rollback. And that's why it is most commonly used deployment pattern, because you can instantly roll back. If there is an issue with the green, you instantly roll back to the blue, and you're good. The other thing is environment separation, where blue-green deployments ensures that the spinning up a parallel green environment doesn't affect the resources support the blue environment, because you're creating a parallel different environment altogether. So it's not going to have any impact on the blue environment, which is currently serving the traffic. So considerations again, cost and operational overhead, because like I've said, you're going to maintain different environment, you're going to maintain a parallel environment. So that's going to be expensive, especially if you are dealing with millions of customers or millions of traffic. You're going to double the cost of your environment. And the backward compatibility, since we are trying to switch from blue to green, and if blue is talking to a data store, and green is talking to a data store or database, we have to make sure that whenever we are switching, it is seamless and it supports version 0 or version 1, because you want to, let's say there is an issue with green, you want to switch back to blue, it has to still maintain the same database and all those things. So that's why backward compatibility is important here as well. So whenever you're trying to do a cutover, like if you're trying to cut over to green from blue, if you plan to decommission the current version, like if you plan to decommission the blue, right, which is the current version, you have to have appropriate connection draining, because the current users are already connected to that blue and they already are trying to do some transactions or sessions, because the current users who are trying to already use blue, they have to be gracefully terminated, or their activity has to be completed before they would start using the green for their next transaction. So now we're going to talk about our famous and most important Canary based deployment pattern, or people also call it as a testing strategy pattern, because you also do a lot of testing in this Canary deployment pattern. And if you watched my previous video on SRE and stuff, this is what Google recommends as well. In Canary, what we do is you deploy a new version of your application alongside with your production version. So version 2 is your new functionality that you have deployed in the application. So you then split the traffic, and you might have seen this in App Engine video that I've done before, and you'll also see this in Kubernetes applications most commonly used. So you route 1% of the traffic, or less than that, to version 2, and then you're going to evaluate the Canary's performance here. So you select the key metrics of the evaluation, whether you want to, when you configure the Canary, and see if that is performing fine. So once you are good with the version 2 and you are satisfied with the results of your few users who are connected to the version 2, basically you are trying to test this with your users, with your live traffic, part of your live traffic to the users. And you can also apply this strategy if you want to roll out to a specific countries or geographical locations. So that can be done as well. This all depends again on your business need and how you want to do this Canary based deployment. But once you're satisfied with that, then you can slowly increase the percentage of users to the version 2. Then finally you will have version 2 running, which is the new functionality for all the users. So this is a Canary based deployment. And now the key benefits here are zero downtime. You don't have any downtime here, because you can route the traffic to the live production to a different versions of application without any downtime. And here it gives you an ability to test the live production traffic. So instead of testing an application by using simulated traffic like we were doing in the blue-green deployment in a staging area, you can actually use Canary tests to live production traffic. So with Canary rollouts, you need to though decide in what increments you release the new version and when you trigger the next step in the release. Also, the Canary needs enough traffic so that you have to monitor those before you would actually know that the version is working fine. So you would put enough traffic to monitor. And now as far as rollback is concerned, you can roll back quickly by redirecting the traffic to the older version of an application, because you're just directing only some percentage of the traffic to the newer version. You can quickly roll back. So that's the key benefits of Canary based deployments. Again, this consideration here is it's a slow rollout, because you're not switching to the green like in the blue-green model. You are slowly rolling out to a set of users, and then you're testing and you're making sure everything is good. So when we talk about observability, it's important that you have enough infrastructure to monitor the traffic that you have put to your Canary. Because, let's say you put some traffic, but you do not have the monitoring tools to observe, or you do not have the metrics, then it's not fruitful to do Canary, because those things will play a huge role whenever you want to now serve 100% traffic to Canary. So observability is important. And the other consideration is the backward compatibility and sticky sessions. Similarly, with the rolling updates here, the Canary can pose users and sessions with the backward compatibility. The session persistent and multiple applications running in an environment while Canary is deployed. So all these factors, again, backward compatibility is important. So that brings us to our final A/B test deployment pattern. Now, A/B testing is used to make the business decisions based on the results derived from the data. When you perform an A/B test, right, so you route a subset of users to the new functionality based on the routing rules. For example, it's based on a filter based traffic, based on a geolocation, or through some conditions, or a browser version, or user agent, or whatever condition that you give. So you route the traffic to the newer version, and it helps you to test your key functionality. So this sort of A/B test based deployment pattern is most commonly used in web applications and mobile phone based apps. So the reason behind this is that before they deliver a lot of changes on the web, if they have changed the way users would click certain elements of the web, so they would first introduce that to a newer version, to a specific geolocation or a specific set of users, and then they want to make sure that they keep that running for some time and see what is the behavior of their website, whether it is improving the performance or whether it is increasing the revenue for some time. There are a lot of strategies. Again, this is commonly used in your mobile phone Android based applications as well. So once they are satisfied with the results, they would switch all the users to version 2, or they might even remove the version 2 as it's not being very helpful for them. So the key benefits here are the measurement, because you are actually measuring against your live traffic. You have a set of metrics that you defined and you are testing against it. So this is very important, and you want to target specific audience and monitor them carefully, and then you're going to take a call. As far as considerations are concerned, it's a complex setup. It's not easy to set up. You need a data analysis, and you want to do all those things to make sure that the newer version is working fine. It's not easy to do it when compared to others. So the validity of the results are also important as well. For example, you might have external promotions or marketing promotions. So there are other factors that are important to consider here. Again, observability. When you run tests, A/B tests on overlapping traffic, the processes of monitoring and troubleshooting can be difficult. For example, if you test product page A versus page B, or checkout page C versus checkout D, distributed tracing becomes important to determine, like where the issue is happening or what went wrong. So now I'm going to show you the summary. So this is the summary as we have discussed all the different strategies. It's not that you have to check everything here, because if you see, only A/B checks everything with respect to releasing to a specific users and stuff. But overall, other strategies also work pretty well. Each has its own pros and cons, right? And if you see, Canary and BG are commonly used, so I recommend highly practicing these two if you are trying to do it in AWS or GCP environments. But again, this is important for your DevOps exam as well. When you're preparing for GCP, keep that in mind, and maybe I'll try to come up with a video on how we can try one of these strategies on Kubernetes or even normal GCP GC based instances. So with that, thank you so much for watching this video. I hope it gave you some important insight on the deployment patterns. And if you like this video, give it a thumbs up and do subscribe to my channel. Thank you all. Bye.